HVAC 360 is brought to you today by Lazy's VR maintenance software. Are you into maintenance but don't like climbing ladders, getting dirty, or hauling tools? Not to mention the hassle of replacing those darn filters. Well, we have the software solution for you. After we load up your building assets into our computer, the only thing you'll have to lift is your VR headset. In no time, you'll have completed your task virtually without even leaving the comfort of your own desk. Get your free consultation? Call Lazy today. Please note that our VR maintenance software does not affect any physical equipment. Actual maintenance, however, can be performed by our VR-linked maintenance robot, sold separately. Hey, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm sharing information and lessons learned in the field and talking with industry experts. But I don't stop there. I want to encourage you to double down in your weekly dose, as always, by going over to HVAC360.com and join my growing community of people just like you. So, what's up for this week? This week, I'm going to take another stab at doing a little article summary for you. Again, this is coming from the spring 2019 version of the High Performance Buildings magazine, and it's a little snippet. This is something, and I'll give High Performance Buildings a plug here. They do have an app, and it is a really good app. I don't read many things, but they do make it easy for you, and they do make it accessible. So it's free. Download it, take a look at it, and it's something that's really well done. So hats off to High Performance Building Magazine. All right, this one is talking about the Helen Summer building. This is one of the new buildings over at the State of Washington campus in Olympia, Washington. This was a case study that they did. And the one thing that kind of piqued my interest about this one is this was about guaranteed performance and taking a look at M&V. So usually when you see this, you see it in kind of an ESCO, at least when I usually see it, I should say. When I usually see this, I see this in an ESCO format. That's a energy services company. And usually what that means is they'll say, hey, you know what, we're going to do this project and it's going to attain these savings. So having said that, they have to then back it up with some measurement and verification. Now, this was a case where it's a new building, so they weren't looking at doing any sort of energy program retrofits. They were actually saying, hey, here's our goal, and their target goal for this one was 30.1 kilobTUs per square foot per year. Which is, if you listen to last week's episode, it was the same thing. They were looking for 30 kilobTUs per square foot per year, again, for an office building. And, that seems pretty reasonable. And really what they did achieve, and in the end, I'll cut to the chase, they actually achieved 25.2 kilobTUs per square foot per year. So they actually achieved a 17% better success rate than what the targeted goal was. Now, the whole thing with this building was they actually had 3 different design teams, I think 3 or 4 different design teams competing for the actual, the right to design it. So they had a design competition, so to speak. And what they did, the winning team came up with a couple of interesting designs. So here's some tidbits and some snippets, a little article summary, if you will, from that article. So what they did is, one of the things is that 75% of the heating comes from a heat recovery chiller and the ground source heat exchangers. So I found that interesting. Again, heat recovery chiller, I don't use that, or I don't see that very often. The one thing in reading the article, and I don't know about you, this is just a quick aside, but Does it bother you that they use in these comparisons about energy savings and being green? They have these proxies that they use. They say that in this one for CO2, they say that by using these energy savings and attaining these goals, we take it's like taking so many cars off the road. Or in this case, they equated it to some propane cylinders for barbecue grills. They do the same thing with water. It's like the reduction in water is equivalent to 4-person household for 6.5 years. I guess to every layman that may make it more palatable. But it's really meaningless to me as an engineer. I look at that and I go, okay, that doesn't make it, so it's like a lot is what you're saying. You're saving a lot because there's really no comparison. There's no benchmark to be, it would be more accurate or more helpful to me if you were to actually compare it to, a standard design. It's a 25% savings over your typical office building, rather than saying, hey, we're saving more than households, more than a 4-person household for 6.5 years. Again, it's kind of meaningless. I don't even know if the lay person really looks at that and finds that meaningful, other than they go, oh, that must be a lot. Okay. Off my high horse, we'll get back to the review. So the one thing they did is, and again, here's a 45.5% potable water reduction. So, good job there. They didn't really talk about it too much in the article about what they did. And I think this is something that, if you go to low flow fixtures, no flow fixtures, you're going to get that kind of water reduction savings as far as usage go. And then again, it's a building, an office building, so there really isn't that much there. The one thing they did say, and I forgot to put it in my notes here, but they did say that what they had done is there was an extra heat exchanger with the ground loop that allowed them to not use the tower water as much. So some of the evaporation they helped there by using a heat exchanger. The HVAC system, so they took a look at it, and obviously, again, we have the best performance balance that they looked at, and they came up with a decoupled ventilation. So surprise! So they used dedicated outside air, and they had zone AC. They did use magnetic bearing chillers. I'll shout that out because I just love those things. So super quiet. And here's one thing I found interesting again. The ground loop heat exchanger was not sized for the full heating. It was just basically, sized for, say 80% of the load, 75% of the load. And the rest of the year, they used a backup boiler to take care of the coldest parts of the year. So I liked that, it wasn't just... They were trying to use and maximize the efficiency, and one way they did that is by kind of splitting the duty of heating the building among a couple different systems. So it can do a lot better using the ground source most of the year, but those colder months, you're going to have to use a backup boiler, which again, I think that's a great design. Now, we had the M&V. That was part of this whole thing because, again, they wanted to make sure that they were hitting that target of 30 kilobTUs per square foot per year. Some of the key lessons is to clearly define the accountability at the start of the performance period. To really figure out, it's all about who's responsible for what bucket of energy. They use the term bucket of energy. I like that. So in essence, what that was is basically, if your tenant comes in there and they're working longer hours or they're working more days than they typically would be, you need to account for that. You need to come to some reconciliation because they've made this system for 30 kilobTUs per square foot per year based on a certain number of assumptions. The same thing with plug load expectations. If the plug load expectations are different, you need to know, okay, who's going to be responsible for that? Is that a tenant that they're saying, hey, you know what? By leasing the space, you got to use a certain amount of plug load. You can't use more than it, or we're going to have to look at options for evaluating that and decreasing that ultimately. Some lessons learned. The HVAC system, and I found this interesting. The zone fan coils that they used were consuming a lot. The fans were consuming a lot more energy than they had originally anticipated. Now, one of the things is that even during no load conditions, they were finding that the fans were running continuously. So they're looking, one of the different M&V energy saving options is they're going to change the sequence to allow for them to run at a minimum CFM during those no load situations. So they're going to reduce the fan load there. Also, the system saves energy by being off when the outside air temperature does allow for it. Therefore, using some passive cooling. They did have operable windows in this particular building, so that allowed them to do some of that passive cooling. Also, one of the other things that they learned is that the server rooms, those plug loads in the space, they didn't use, they used about what they would expect, maybe even a little bit less. But in the server rooms, they were using more power than anticipated. So again, that didn't jive with the original plan for 30 kilobTUs per square foot per year, but they went back and they talked about it a little bit more. Now, one thing that they did say is that M&V coordination is really critical when you do this sort of performance evaluation. And you want to make sure that whoever is doing the M&V coordination for you is really on board early, because you want to be able to work out with the temperature controls contractor what values are showing up and who's doing the analysis. You want to be able to make sure that whatever data is coming into this M&V analysis is going to be good, valid data, and that it's not reading the wrong point. It's not there's no multiple that's being fed in there incorrectly, and that in fact is what it says it is, so to speak. So there's a lot of coordination goes in, and that's important to do before you start taking a look at your performance period. You don't want to have garbage data. Obviously, that the garbage in, garbage out. So if you take that garbage data in and you do your analysis, then your analysis is based on incorrect information. So you want to be able to avoid that. All right, well, that's the summary of that article. Thanks so much for listening. I hope this was helpful. If you know anybody who's out there looking for more M&V information about this topic or any others, consider passing this episode along. I mean, it really does help out. Just recommending this to some younger engineer, recommending this to just anybody else in the office. I really do appreciate that. If you're not a subscriber, consider joining the community over at HVAC360.com for some more weekly goodness. And lastly, I'd be greatly honored if you'd go over and give me a rating and review on Apple Podcasts. Also, if you want to subscribe to the YouTube channel, HVAC360.com YouTube channel, I greatly appreciate that. That allows me, or will allow me, to do some fun things in the future. So, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.